Hello students, today's topic is normal forms. It includes disjunctive normal form, conjunctive normal form, principal disjunctive normal form, principal conjunctive normal form. Before going to all these, first you have to know the definitions. Elementary products and elementary sums. Okay. See the definition. This is normal forms. Elementary product. Elementary product. Elementary product means the product of the variables and the negations in a formula is called elementary product. The product of variables and their negations in a formula is called elementary product. It's called elementary product. Okay. For example, P and Q, P and negation Q, negation P and Q and P. These are all elementary products. Product is nothing but conjunction. You can understand. These are some elementary products. Elementary sum. That is the sum of the variables and their negations. Okay? The sum of the variables and their negations is called elementary sum. For example, P or Q. P is itself an elementary sum. Okay? P or Q. Negation P or negation Q. Negation P or negation Q or P. These are all elementary sums. Next definition, factor. Factor means any part of elementary sum or product. Any part of elementary sum or product which is itself elementary sum or product, which is itself elementary sum or product is called a factor of the original. It's called a factor of the original elementary sum or product. Okay. Factor means that is a part of elementary sum or elementary product which is itself elementary sum or elementary product. Okay. It's called a factor of the original elementary sum or elementary product. Okay. See an example. Suppose the given formula is P and negation Q and negation P. This is the given formula. Then the factors are P and negation Q, P and negation P and P. These are factors. The factors of the given formula. Okay. Since these are parts of the original elementary product. This is elementary product here. Okay. Now P and negation Q, P and negation P, P. These are parts of the given formula. Okay, and hence these are factors. Okay, disjunctive normal form. Disjunctive normal form. What is a disjunctive normal form? A formula which is equivalent to given formula and consists of sum of the elementary products. Okay, a formula which is equivalent to given formula and consists of a sum of the elementary products. Sum of the elementary products is called disjunctive normal form. Disjunctive normal form. That means disjunctive normal form is sum of the elementary products. Okay. See the example. P and Q or P and negation Q. This is an example of disjunctive normal form since this is sum of the elementary products, right? Next problem. Obtain a disjunctive normal form. Disjunctive normal form of P and P implies Q. Okay, you have to find the disjunctive normal form of this P and P implies Q. What is disjunctive normal form? That is sum of elementary products, or simply you can say that is disjunction of conjunctions. Disjunctive normal form means. Okay, see the solution. P and P implies Q, which is equivalent to, logically equivalent to P and, you know that P implies Q is equivalent to negation P or Q. Okay, since P implies Q is equivalent to negation P or Q. Okay. That is equivalent to, now by distributive property, this can be written as P and negation P, P and negation P or P and Q by distributive property, by distributive law. Okay. Now see this. This is disjunction of conjunctions or sum of elementary products. These are elementary products. Okay. Sum of elementary products, and hence this is required. This is required. Disjunctive normal form. Disjunctive normal form. Okay. Next problem. Obtain a disjunctive normal form. Disjunctive normal form of P implies Q and negation Q or negation P. You have to obtain a disjunctive normal form of this. What is meant by disjunctive normal form? That is sum of elementary products, or simply disjunction of conjunctions. Okay. See the solution. P implies Q and negation Q or negation P. This is equivalent to, you know that P implies Q is equivalent to negation P or Q. That implies negation P or P implies Q and negation Q or negation P. Okay, since P implies Q is equivalent to negation P or Q, that is equivalent to negation P or, again P implies Q, can be written as negation P or Q, and this is by De Morgan law, negation of negation Q, and negation of negation P is P. Okay. Since again P implies Q is equivalent to negation P or Q, the reason for this. Okay. And by De Morgan law, understand, that is equivalent to negation P or, now apply distributive law, negation P and P or Q and P, negation P and P or Q and P. Okay. By distributive law, this is equivalent to negation P or negation P and Q and P. This can be written as negation P and Q, or Q and P. Okay, now negation P and P, Q and Q. This is by commutative law and this is by associative law. Okay, by commutative law and associative laws. Okay, that is equivalent to negation P or negation P and P is equivalent to F and Q, or Q and Q is equivalent to Q and P. Since negation P and P is equivalent to F, okay, and Q is equivalent to Q. Now this is equivalent to negation P or F and Q means F, or Q and P or P and Q, no problem, since by commutative law. Since F and Q is equivalent to F and by commutative law, Q and P can be written as P and Q. Okay. Now this is equivalent to negation P or P and Q. Since P or F is equivalent to P. Okay. And hence this is the equivalent to negation P or P and Q. Now this is sum of the elementary products or disjunction of conjunctions. This is required. Disjunctive normal form. DNF means disjunctive normal form. Next, conjunctive normal form. Conjunctive normal form. A formula which is equivalent to given formula, and consists of the product of elementary sums. Is called conjunctive normal form. conjunctive normal form of the given formula. Okay, conjunctive normal form means it consists of product of elementary sums, or simply we can say that this is conjunction of disjunctions. Okay, next problem. Obtain the conjunctive normal form of P and P implies Q. P and P implies Q. See the solution. Given formula is P and P implies Q. Now this is equivalent to P and P implies Q is equivalent to negation P or Q. Since P implies Q is equivalent to negation P or Q. Okay. Now this is product of elementary sums. That means conjunction of disjunction. This is required conjunctive normal form. Conjunctive normal form. CNF means conjunctive normal form. Next problem. Obtain the conjunctive normal form of negation of P or Q by implies P and Q. Negation of P or Q by implies P and Q. We have to find conjunctive normal form of this. Conjunctive normal form means that is conjunction of disjunctions or product of elementary sums. Okay. See the solution. Negation of P or Q by implies P and Q. This is equivalent to negation of P or Q implies P and Q, and P and Q implies negation of P or Q. Since P by implies Q is equivalent to P implies Q and Q implies P. P by implies Q is equivalent to P implies Q and Q implies P. Using this formula, we can write like this. Okay. This is equivalent to P or Q or P and Q. Since P implies Q is equivalent to negation P or Q. And now again using the same formula, P implies Q is equivalent to negation P or Q. This is negation of P and Q or negation of P or Q. This is the reason, since P implies Q is equivalent to negation P or Q, right? Now this is P and Q. Okay. Now by distributive law, this can be written as P or Q or P and P or Q or Q. By distributive law, okay. P or Q or P and P or Q or Q. Okay. And negation of P and Q, that is negation P or negation Q by De Morgan law, or again negation of P or Q, negation P and negation Q. Okay, this is by distributive law and this is by De Morgan law. Okay, by distributive law and De Morgan law. Okay, this is equivalent to P or Q or P, means P or Q only. P or Q, and this is P or Q or Q. This is also P or Q. And now apply distributive law for this. Negation P or negation Q or negation P negation P or negation Q or negation P and negation P or negation Q or negation Q. Okay. By distributive law. By distributive law. And commutative law. Commutative law. And P or P is equivalent to P. Okay. These are the reasons for this. Okay. Now this is equivalent to, you can write P or Q and P or Q as P or Q. Since P or P is, P and P is equivalent to P. Okay. And now this is negation P or negation Q. Okay, since negation P or negation P is negation P, and this also negation P or negation Q. Since negation P or negation P is equivalent to negation P. Okay, since negation P is 2 times here, negation Q is 2 times here. Okay, now you can write this as P or Q and negation P or negation Q 2 times negation P or negation Q. Okay, since P and P is equivalent to P. Okay, conjunction of disjunctions or product of elementary sums. These are elementary sums. Okay, product of elementary sums or conjunction of disjunction. That's why this is required. This is required conjunctive normal form. CNF means conjunctive normal form. Okay students, please do subscribe my channel and share it to your friends. Thank you so much for watching. See you in the next video.